A water tank has a height of 2 meters. The depth of the water in the tank is h meters at time t minutes after water begins to enter the tank. The rate at which the depth of the water in the tank increases is proportional to the difference between the height of the tank and the depth of the water. Write down a differential equation in the variables h and t and a positive k, constant k. You are not required to solve your differential equation. Another water tank is filling in such a way that t minutes after the water is turned on, the depth of the water x meters increases according to the differential equation here. The depth of the water is 1 meter when the water is first turned on. Solve this differential equation to find t as a function of x. Calculate the time taken for the depth of the water in the tank to reach 2 meters, giving our answer to the nearest 0.1 of a minute. So let's work through the question, and I've got it in summary form here. So I'm just going to work on the first part of the problem. So let's move this second part of the problem down below, and we'll come to that in due course. So the first part of the problem then, the tank height is 2 meters. So we've got a tank. Its height is 2 meters in total. Depth is h meters at a time t minutes. So this height here is h at time t. The rate at which the depth of water increases, the rate of increase of depth, so dh dt, the rate of increase of depth of water, increase is proportional, so equals k times the difference between the height of the tank and the depth of water. So that is that length there, which is 2 minus h, isn't it? That difference, take away that, so it's 2 minus h. Okay, so we need to write down a differential equation involving these variables. Let's look back at the question then, just to check that. Write down a differential equation in the variables h, t and a positive constant k. So we've done that bit. Now let's move on to part 2 then. So there's our differential equation. Part 2 then. Let's turn our attention to this one. Just put it in the right position. Okay, so let's have a look here. Another tank is filling after t mins. The depth is x meters given by this differential equation. The depth of water is 1 meter initially. So when t equals 0 then, the depth of water is x, so x is equal to 1. So that's the initial condition. Solve this to find t. Okay, so let's have a look then. So separate the variables, bring the 15x up, and it's 2x minus 1 to the half. Dx can be there. So this is b. So I've just moved these two terms up to be here to be along with the dx, and the 1 to be with the dt. Separate the variables and integrate it. Okay, now we need to integrate this. So let's try a substitution on here then. So let u equal 2x minus 1. That will be u to the half, and then du dx is equal to 2, isn't it? Just differentiate this. And also we can then get 15x. So x will be u plus 1 over 2, isn't it? U plus 1 divided by 2. So that's what we've got then. So this integral then, this will be, this right hand side integral is just t, and I'm going to label this left hand side I equals then. So it's the integral of, let's use the substitution, 2x minus 1 is u to the half. We've got the 15, and then we've got x, which is u plus 1, over 2, and then dx, which is du over 2, isn't it? So that's equal to 15 over 4, just take that to the front. The integral of, so the 15 over 4 can go there. U to the 3 over 2 when we expand this bracket, plus u to the half du. So that's equal to then 15 over 4, not solve. Raise the power by 1, divide by that number, plus u, raise the power by 1, divide by that number. Okay, we'll put our plus k in at the end, so I'm just doing the integration now, which is equal to, the 2 comes up to be with the 15, to make 30, so I'm going to write it as a full fraction, 30 over 20, 4 5s are 20, u to the 5 over 2 plus, and then the 2 comes up 30 over 3 4s are 12, u to the 3 over 2, plus a constant of integration, which we'll worry about in due course. So it's 3 over 2, u is 2x minus 1, so 5 over 2, plus 30 over 12, divide by 15 over 6, divide by 6, 5 over 2, 5 over 2, u to the 2x minus 1, isn't it, to the 3 over 2. So what have we got here then? Well, we've done the integration, and then we can just add a k, can't we, because this is just t. So we can put a plus k in without any harm, here and here. So I'm just going to just copy that if I can. And then we can just put that equal to t. So t equals then is equal to this. So there's our equation. Solution. So calculate to find t. Oh, we've got an initial condition. The depth of water is 1 meter initially. Solve to find t. So t equals 0, x equals 1 gives. So t is 0, x is 1, so 1 in here. 2 1s are 2, so that's 1, so that's 3 over 2. And then we've got another 1 in here, so that's going to be 5 over 2, plus k. So we get 8 over 2, which is 4. K is minus 4. So there's k. And so that gives us t is equal to 3 over 2, 2x minus 1 to the 5 over 2 plus 5 over 2, 2x minus 1 to the 3 over 2 minus 4. So there's our solution then. Now we move on to the second part. Calculate t for depth to reach 2 meters to the nearest 0.1 meter. So when the depth x is 2, x equals 2 then gives t equal, well this is 2, 2's are 4, 4 minus 1 is 3, so it's 3 over 2 times 3 to the 5 over 2 plus 5 over 2 and then 3 to the 3 over 2 minus 4. So let's just tap that in the calculator then. 3 over 2, which is 1.5, times 3 to the power 5 over 2, which is 2.5, plus 5 over 2, which is 2.5, times 3 to the power 3 over 2, which is 1.5, down to ground level, minus 4, equals, and it's to the nearest 0.1 meter, so it's 32.4. 32.4. Nearest 0.1 something, wasn't it? 0.1 second probably. The time, isn't it? Minute. That's mins. 0.1 minutes. 32.4 mins.